All right, so here's the definition that we're going to be using to try to find these functions without having to take, one derivative, two derivatives, three derivatives, etc., over and over again. So, definition of the nth Taylor polynomial and Maclaurin polynomial. You'll notice the Maclaurin is basically the same idea, just that if it's centered at 0, we call it a Maclaurin. If it's not centered at 0, then it's called a Taylor. Okay, so definition looks like this. If f has n derivatives at c, then the polynomial p sub n of x, which would be equal to f of c plus f prime of c x minus c plus f double prime of c times x minus c squared. And this would be a 2 factorial here. Now this is going to be kind of long. I'm doing this on purpose so you guys can see the pattern, okay? And then we're going to I'll put it down here, plus f to the nth prime at c of x minus c to the nth over n factorial. It's called the Taylor polynomial for f. Excuse me, at c. So let me give you a little bit of time to write that down. All right, so there's a second part to this, and it's kind of like an easier one. They say if c equals 0, then, so if c is 0, then p sub n of x. Yeah.
What do you mean by C is the center?
That's where it's centered. That's where we're focusing on the function. It's just, it'll make a lot more sense once we start talking about interval of convergences and stuff like that. So right now we're not talking about it yet, but once we get to it, it'll make a lot more sense as to why it's called the center. But if I could give you a real quick look into it, it's something like this. At some point, we're going to say, okay, a function might be centered at 3. So where does it converge? And then we start finding out its radius of convergence. And once we know its radius, maybe we find out that it converges from 1 to 5. So notice how 3 is the center of that interval. So that's kind of what they mean. But we'll get to that part a little later. I don't think it's this lesson. It might be the next one. But yeah, we will get to that. So if c equals 0, then p sub n of x is f of 0 plus f prime at 0x plus f double prime at 0x squared over 2 factorial plus etc. plus f to the nth prime at 0 x to the nth over n factorial. That's called the Maclaurin polynomial for f.
It would give us or will we have to find it?
Yeah, they're normally going to give you the function that you're going to have to try to mimic. So you'll notice what they basically did is they put 0 for c. So instead of having a bunch of x minus c's like we did in the previous polynomial, x minus c would be x, right? Because our c value is 0. So all those x minus c's disappeared, and they just end up with x's, x squared, x cubed, x to the fourth, etc. And that's what we call our Maclaurin polynomial for f. Now, just so you guys know, more times than not, the Maclaurin polynomial is the one that shows up in the AP tests because it's easier. They don't want you guys struggling so much to do that. You still know the process if you use Maclaurin or Taylor. So usually it's Maclaurin, but every once in a while they will throw in a Taylor polynomial. So make sure you know both. Like I say, to me, it's more important you know the top polynomial, the one, this one right here. Because if you did get a 0 center, you could just plug it in and you could create your own Maclaurin, right? You don't have to memorize both. Okay, just the Maclaurin, if they tell you it's Maclaurin, just let c equal 0 and plug it in. And you'll get your new formula. Okay, so easier for you just to memorize the general one instead of the specific Maclaurin one. Okay, so let me show you guys what we're going to do with this. So I know it's going to be pretty much like the same example again, but now you're going to see it done a different way. So find the nth Maclaurin polynomial for f of x equal to e to the x. Again, I know we're using the same function, but I just want you guys to get used to it with one. We'll move on to sine and cosines and stuff right now. Okay, but let's find the nth Maclaurin polynomial. So the first thing you got to do, this is actually the first thing I always do, is I write out my function. Okay, so this will be x plus f double prime at 0 of x squared over 2 factorial plus etc. Actually, we could go with the third and then we'll do the etc. So f triple prime at 0 of x cubed over 3 factorial plus then f to the nth at 0 of x to the n over n factorial. And now all I have to do is follow the instructions that they tell me. Okay, because all the x's, they're already set. I just got to figure out the coefficient. So, p sub n of x. What's f of 0? That's a 1, right? So 1 plus, what's f prime of 0?
1.
Also 1, so it'd be 1x. What's f double prime of 0? 1 over 2 factorial, so that'd be half x squared. What's f third derivative at 0? It'd be, well, 1 over 3 factorial, which would be 1/6 x cubed plus, and then our last part, well, f to the nth factorial, I'm sorry, f to the nth derivative of 0 is going to be a 1, right? So it's x to the n over n factorial. And that's your answer. Notice how I didn't have to find a polynomial and then derive it little by little, break it apart, set it equal to the derivative portions, right? I just basically used the general formula to do the pattern.
We should always go up to 3.
I always go to 3 just so I can get a couple of terms. Yeah, 3 or 4 if you have enough space, because sometimes they'll have you take a derivative of this in the AP test. So you got to take a derivative of that. And if you only do like 2 terms, then after, say, the third derivative, you have nothing to look at. So yeah, going about 3, the third degree would be good. Yeah, it doesn't hurt. And remember, it's just a pattern. So it's not like you're doing a bunch of extra work, right? You're just kind of following a little pattern and completing it. But yeah, I wouldn't say go to the 4th degree unless there are problems on the AP exam where they say write the 5th degree Taylor polynomial. Well, in that case, write all 5, right? I mean, that's all you have to do. So go ahead and do all of them.
When they say that, do we stop at 5? Or
If they say 5th degree, you got to get to the 5th derivative. Yeah.
and then we don't do the x?
Don't do the x, no, unless they say to write the nth term or the general. They might say the general term. All right. So let's change this up a little bit. So before we do sine and cosines here, let me give you this problem. So they want us in this case, whoops, sorry about that. We're going to find the Taylor polynomial p sub 0, p sub 1, p sub 2, p sub 3, and p sub 4 for f of x equal to ln of x centered at 1. Now for this one, I am not going to do it using a formula. I just want to practice one more time. Well, we're going to use a formula, but we're not going to use the old-fashioned formula. The one with the a sub 0 plus a sub 1x plus a sub 2, all that stuff. We're not going to use that one. We're going to use the one that we learned, okay? And then use that to help us figure this out. Now notice they want the 0th degree polynomial, and then the first degree, second degree, third degree, fourth degree. Okay? So if they want me to go all the way up to the fourth degree, then I need to take the fourth derivative. So let's do that. So we start with f of x, which is ln of x, f prime of x, which is 1 over x, f double prime of x, which is negative 1 over x squared. Go ahead.
What does it mean that it says centered at 1?
That means your c value is 1. Yeah, c is equal to 1. If we do the next one, the third derivative, then let's see, that would be x to negative 2, so it would be a 2 over x cubed. And the fourth derivative would be a negative 6 over x to the fourth. Now we're going to put in the center, so f of 1, that'd be ln of 1, which is 0. F prime of 1, that'd be 1. F double prime at 1 would be a negative half. F triple prime at 1 would be a 2. Oh, what am I saying? Yes, negative 1. Sorry about that. And then f quadruple prime, right, fourth derivative at 1 would be a negative 6. Are we okay with how we figured those out? So we just plug them in, right? So notice now we know our derivatives. Okay? We know our derivatives. So they want us to find, let me write this out, p sub n of x. They want us to go up to 4, right? So let me put a 4 here. Now this would be my 0th degree, okay? That's the 0th degree. And then when I put this one in, this is my first degree, second degree, third degree, I'll put the fourth degree on the bottom. So when they say they want the 0th degree, they just want this one, okay? When they say we want the first degree, then you got to include this. When they want the second degree, then include this. If they want the third, you keep going, okay? You just keep adding to it, all right? So even though I wrote 4 terms, actually 5, because the 0th degree counts as an extra, we're only going to take pieces at a time. So here we go. P sub 0 of x. Well, that just means f of 0. What's f of 0? That was 0. So there you go. There's p sub 1 of x. Sorry, p sub 0 of x. It's just 0. It's the first piece, f of 0. Or f of 1, sorry. I was saying f of 0. F of 1. All right. Now, let's find p sub 1 of x. So in other words, I need f of 1 plus f prime of 1, x minus 1. Okay, the c's are going to be 1s. So it's going to be f of 1 plus f prime of 1 times x minus 1. I'll write that over here, by the way. That way you guys can see where I got the 0 from. Well, we found out that f of 1 was 0, right? So that's going to be 0 plus f prime of 1. That's a 1 times x minus 1. So your answer is x minus 1. Now, a lot of times with Taylor polynomials, they like to have these things in ascending order, which means they would prefer your answer to look like this. Okay? Start with your coefficient if you have one, and then go with your variables in order. Okay? So there's that one. Now, p sub 2 of x. They want f of 1 plus f prime of 1, x minus 1, plus f double prime of 1, x minus 1 over 2 factorial. So I just got to get my numbers. So we know f of 1 was 0. We know f prime of 1, x minus 1 was, I'm just going to write here, x minus 1. We found that earlier. Okay? From the previous answer. Or actually, if you want, you can write it in the correct order now. Negative 1 plus x. And now I just got to do f double prime of 1. So f double prime of 1 was what? Negative 1, yeah. So I'm going to put negative 1 over 2 times x minus 1. So let's write it out. Negative 1 plus x minus half x minus 1 squared. Yeah, it should be squared. Sorry about that. I just noticed I didn't put it there. But they should all be squared. So there's that answer. Now, we're doing this multiple times. They probably won't make you do this on an AP exam, but it's just for practice right now, okay? So p sub 3 of x, that would be f of 1, f prime of 1, x minus 1, plus f double prime at 1, x minus 1 over 2 factorial, plus f triple prime at 1, x minus 1, I forgot to put the squared there, cubed, over 3 factorial. Okay, so that's what it's going to look like, putting everything together. So let's plug in f of 1. So that's 0 plus negative 1 plus x plus the next term was negative half x minus 1 squared plus, now I got to do the third one. So f triple prime of 1, what was that, a negative 2? A positive 2? I got to go back up. Yeah, positive 2. And then a negative 6 is next. So this will be a 2 over 6 x minus 1 to the third. So let's clean that up. That's going to be negative 1 plus x minus half x minus 1 squared plus 1/3 x minus 1 to the third. Do you guys see the pattern?
Yeah.
So what's the next one? Without even writing out a formula. It should be negative 1 plus x minus x minus 1 squared over 2 sorry, 1 over 2 plus x minus 1 cubed over 3. What's the next one? Minus what? There you go. Now I'm going to tell you that there are some polynomial expressions you guys have to memorize, okay? It's going to be for your own good. Know what e to the x looks like. Know what ln of x looks like, so you can see it right here. Okay, recognize the patterns for sine and cosine. There's 4 of them that you guys need to know. Okay, so so ln of x looks like this. E to the x, I think we did it earlier. Let me just check. E to the x is actually, it looks like it's more difficult, but if I can change it for you, it's like this. So it's just the factorial on the bottom for e to the x. Okay? Whereas ln of x doesn't have a factorial, it just counts. Right? 0, 1, 2, 3, 4, 5, 6 in the denominator. It just keeps counting. Okay? So for e to the x, it has the factorials. For ln of x, it does not. Okay? And they'll be in your book. I'll tell you where to find them. But that's when we want to memorize. Okay? Something like natural log. Because the thing is, a lot of times they'll say like, find the 4th degree Maclaurin polynomial of cosine. You should be able to write that out in like 10 seconds instead of having to work your way to it. Because remember, you're being timed, right? So when you're being timed, you're going to have to be able to reciprocate these things quickly so that you have more time to work. Usually they'll give you sines and cosines. Usually. Every once in a while you get e to the x and natural log of x's. You don't want to waste your time doing this. Okay? So it's best to memorize what the patterns are. Okay? Again, for sine, cosine, e to the x, ln of x. So let me move on to the next one. Okay? So let's find the same thing for cosine of x. So find the Maclaurin polynomial. So what's my center? 0, right? For p of 0, p of 2, p of 4, for f of x equal to cosine of x. Then we're going to use p sub 4 of x to approximate cosine of 0.1. We may stop after this one. I think this might be a good one to stop at. So I need p sub 0, p sub 2, p sub 4, right? My 0th degree, 2nd degree, 4th degree polynomial. So in order to do that, I got to get my function, which is cosine of x. And I'm going to take 4 derivatives. So negative sine of x. Second derivative, negative cosine of x. Third derivative, sine of x. And fourth derivative, cosine of x. Now, they did say Maclaurin, right? So that basically means c equals 0. So let's figure those out. F of 0, that's 1. F prime of 0 is 0. F double prime of 0, negative 1. f triple prime of 0, 0. F quadruple prime at 0, 1. All right, now let's write our 0th degree, 2nd degree, and 4th degree polynomial. So, let me write this out again. This is something I used to do all the time whenever I did these problems. I wanted a reference. So, f of 0, f prime of 0, x. F double prime of 0, x squared over 2 factorial. F triple prime at 0, x cubed over 3 factorial. F quadruple prime at 0, x to the 4th over 4 factorial. That was my reference so that I knew exactly what I had to do. So let's find the 0th degree. 0th degree is just f of 0. What is that? 1. So I'm done. That one's finished. 2nd degree. Well, that would have to be f of 0 plus f prime of 0x plus f double prime of 0 x squared over 2 factorial. So f of 0 is 1. What's f prime of 0? 0 times x is 0, so I don't need to write it. That's why they didn't make us do a 1st degree, because there is none. Okay? And then we go to the 2nd one. So 2nd one, f double prime is negative 1 over 2 factorial x squared. So it's going to look like this. 1 minus x squared over 2 factorial. I'm going to leave it in factorial so you guys can see the pattern, okay? Now p sub 4. That would be f of 0 plus f prime of 0x plus f double prime of 0x squared over 2 factorial plus f triple prime of 0x cubed over 3 factorial plus f quadruple prime of 0x to the 4th over 4 factorial. So, f of 0 is 1. F prime of 0x, that's 0, because it's 0 times x. F double prime of 0, x squared 2 factorial, that's a negative 1 over 2 factorial x squared. What's f triple prime of 0? 0. So 0 times x cubed over 3 factorial is 0. So then f quadruple prime. Well, that would be, what was quadruple prime? 1. So that'd be 1 over 4 factorial x to the 4th. So let me write this out. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. Which powers are remaining? The evens. Even the x to the 0, right, which is 1. It's x to the 0 over 0 factorial. X squared over 2 factorial. X to the 4th over 4 factorial. So if I were to tell you, write a general formula for this function, you should write 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. Which should be next? X to the 6th over 6 factorial, but plus or minus? Negative, right? And then x to the 8th over 8 factorial, etc., 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 right? You guys should be able to do that. if they ask you, hey, can you give me the nth term? Well, you know it's oscillating. Actually, that would be n minus 1. Actually, no, it should be the 0th term, right? So 2 to the n. Nope, that can't be right. Hold on. I'm thinking this the wrong way. It's oscillating, so negative 1 to the n. Let me see. N. If I plug in, if I want the 0th, that would have to be positive, so that would be right. Yeah. And then it would be x to the 2n over 2n factorial. But memorize that cosine has even powers. Go ahead.
In the last example, we didn't do the factorial in the denominator, and this one we did.
I did do it. I changed it. Right now, I'll go back. Oh, you're talking about this one right here? Yeah, because the factorial actually cancels out. So I want you guys to notice that when natural logs, it doesn't have the factorials on the bottom. The powers match the denominator exactly. For e to the x, the power, where is it at? The power matches the denominator, but it is in factorial form. So for e to the x, it's in factorial form. For ln of x, it's not. And then for sine and cosine, they will be back into factorial. So, what was I going to show you guys here? Let me go back. Now, we didn't finish this problem. Like I said, this is going to be the last problem. But they want us to approximate using the fourth, this one right here. Approximate cosine of 0.1, which basically means find that using our fourth degree polynomial. So in other words, we're going to plug it in. 1 minus 0.1 squared over 2 factorial plus 0.1 to the 4th over 4 factorial, which is approximately 0.995. So we'll stop there.